Dear all, welcome to this third part of the webinar. I see still people are joining, so let's give some more time, maybe 1 more minute, then we'll start our session of part 3, the big assembly adventure. Okay, good afternoon all. It's time to start our webinar. People are keep on joining, but we can start our webinar. So I would like to welcome all of you for this SolidWorks technical webinar series. Okay, so this one is part 3 of our big assembly adventure, which is taming the large assemblies in SolidWorks. Okay, to brief about myself, I'm Sarana Prakash. I'm a technical account manager for all the strategic accounts. I have totally 20 years of experience. I worked on almost 19 years in all type of leading manufacturing industries. I have lots of experience on this one. So to give my credibility to talk on large assemblies, I've worked very, very large assemblies in my experiences. I can say I have handled maybe 20,000 components assemblies, which is from the scratch, it was built. So as you aware, the first one, the first webinar was conducted on June 6 by Nilesh, where we have covered many proven strategies and performance optimization of the SolidWorks. So mainly, what are the options available in the SolidWorks to handle the large assemblies? So that is the main agenda of that meeting. Okay, so and in part 3 also we are going to see some of the which was not part of the part 1. We are going to see in part 3 because of time limitation. We have split it into different parts. In part 2, Mr. Prasanna was taken the handling or working with neutral CAD files, okay, which is very, very essential when coming to handling the large assemblies. And now we are in part 3 of this one. So what we are going to see, we are going to see multi-CAD collaboration and large assembly management, which is we can do it through our SolidWorks options, and case studies. I have 2 interesting case studies where I'm directly involved in customer interfaces. I've discussed, even I've part of the experimentation to resolve customer issues in the large assemblies. So that will be much more interesting. So we can talk about it. So if you have any questions at any point of time, you can feel free to put the questions in the question and answer box. And I'm not sure how many of people have been part of part 1 or part 2. If you have missed any of the previous parts, no need to worry. So you can take this as a screenshot, okay, so that you can scan it and always have access to the part 1 and part 2. Okay, so in this webinar, what we are going to see only the 4 broad topics: how a multi-CAD collaboration can be done effectively, and the best practices for optimal performances, and the power of 3D Experience SolidWorks, where I'm going to cover very little bit on 3D Experience SolidWorks and the practical case studies. As I already told, we are going to see the case studies also. So before we begin, okay, I would like to understand more about you on some of the questions. Let me launch a poll questions, which will be easy. Yeah, I've launched the poll, so I request all of you to answer the poll questions. The first question is, did you get a chance to attend the past webinars? I can see mixed answers here. The second question is, how familiar are you with multi-CAD collaboration and challenges it presents? Completely familiar, somewhat familiar, or not familiar at all. That means you are completely new. Okay, how many CAD softwares does your company or your team deals with, including vendors? Maybe internal teams, or you're going to deal with your vendors. Yeah. So we have crossed 1 minute. I'll open this poll for next 40 seconds. See, I can see lots of participants, but I'm just getting a very low number of answers. I would like to answers from everybody. Okay, so we have got all the poll responses. So most of you have not been part of part 1 and part 2. What I suggest is to just access through our QR code, so that you will get access to both of our previous webinars, which will be much more helpful in your knowledge learning and knowledge transfer also. Okay, so okay, almost half of the people are want to learn more about multi-CAD collaboration. Okay. Just let me close the poll here. Okay. Thanks for all of you for answering the poll questions. So first in our subject is, we are going to see how a multi-CAD collaboration works. Okay. So when you are working with large assemblies, maybe in your organization, multiple teams or multiple vendors, you have two choices how you can perform this activity. Either you can get the native files. That means if some of your team members are using Creo or NX, you can directly get the NX files or Creo files and use it. And one more choice is to get the step files. That means neutral files. Okay, or Parasolid, IGS, or different any other neutral CAD files. Okay, it may be either from vendors or internal teams, maybe anywhere. So out of these two choices, which one is widely used? Whether choice 1 or choice 2, and which one is preferred? So we are going to answer these questions in coming slides. Okay, so the choice 2 is more widely used because of people are unable to get a chance to learn about how to work with native CAD files, especially in SolidWorks, who are using SolidWorks, or people are restricted only of getting the neutral CAD files. Okay, and the complete handling of neutral CAD files in the large assembly perspective has been covered widely in part 2. You should not miss that one if you are handling the neutral CAD files. Okay, so when possible, native CAD files is always preferred because in SolidWorks, we have a tool called 3D Interconnect. Okay, so in this 3D Interconnect, what it can do, it can directly open the native CAD files into the SolidWorks. So any third-party softwares, any third-party CAD models, we can directly open into SolidWorks. So by doing this one, no translation necessary. So if you know, during the neutral CAD file modification or conversion, so there will be lots of errors will be possible to happen, and the translation errors will be coming. Okay, so in this case, no translation is necessary. That means you can use as it is. So also using the legacy 3D designs from your tools already won. And this will give a much more flexibility, as I already told, working with your internal teams and vendors of your various manufacturers or vendors. So one more advantage of using the 3D interconnect is so intelligent knowledge of third-party design tools. That means if you are using any third parties CAD models, say assume Creo. Okay, so if you are getting any models from Creo, you can use it inside the SolidWorks without doing any conversion, so that all the faces and edge IDs will be preserved. For example, if that same Creo model is going to be revised, okay, for next level of revisions, you just need to put it the revised CAD files in the same folder path, so that when you open the assembly in the SolidWorks, you just need to just update or refresh it, so that all the changes which is made into the Creo files will be reflecting here. And it will also understand the CAD version files. As I explained, the different versions. So whichever the newer version, that will get updated here. So this is the major advantage of the 3D interconnect. So because of these advantages of directly handling the third parties CAD files, so we can see the greater performances and faster opening times. Okay, so to answer the first questions which I've raised, okay, which one you need to prefer? So you have always, if possible, always prefer to get native CAD files first. Okay, so that we'll have a lots of larger plus points using the native CAD files than neutral CAD files. In 3D interconnect, there are various workflows. Okay, so especially you can directly insert the third party's CAD model here, and you can use it like a native SolidWorks file, so that you can mate it, and you can do whatever you are doing currently with the SolidWorks. That means without any modification and all. So, or if already you have a other third-party CAD, but you want to add some more features, you can always add. Okay, because of the edge IDs and other things are going to be preserved. So whenever you're going to change the basic part in the from the some other CAD, this will be updated also. Or if you want to make a complete changes, or you want to independently do the changes in the third-party CAD, you can always do by breaking the link. Okay, so this will ask you to perform the feature recognition. Okay, so we can use effectively feature recognition also, so that most of the features will be recognized. As I already said, by breaking the link, still breaking the link, we can have the preserved faces and edges, edge IDs as it is, so that when neutral CAD file, native CAD file is going to change, so that we can also easily implement in the 3D using the 3D interconnect. Okay, so if you wonder where I need to access this 3D interconnect, you can see this video. You have to go, if you have attended in previous part 2, this is explained, but anyway, here we can do this one. So you have to go to options and tools. You can see how to enable 3D interconnect or disable it. You can see what are all the other options available. Currently, the 3D interconnect is defaultly checked. That means it is defaultly available. So you no need to go and change it, unless otherwise there are some other advantages. In part 2, we have explained when it is positive, not to use 3D interconnect in some cases, not in major cases. So here you can access the 3D interconnect. Okay, if you have any doubt what all the versions of the other CAD files can be supported here, you can see Autodesk Inventor here. So this will be from 2011 to 2023 versions are supported. In CATIA V5, so all the for CATIA V5, so you need a SolidWorks Premium. So then only you can use the CATIA V files directly. So from version 5 revision 8 to version 5, version 6, CATIA 6 up to 2022, you can use it. So you can see IGS up to 5.3. You can see for Creo up to Creo 9. So which is latest from Pro Engineer 16 to Creo 9, you can use those legacy CAD product data. Solid Edge, you can see up to 2022. In NX, you can see up to NX 2022, current NX format. Okay, so this is how you can effectively use, so that you won't miss, even if your vendors or in your team, you are using a very older version of CAD softwares. You can still use all those files in your SolidWorks. Even in latest SolidWorks, you can use it. Okay, so we are talking about it. So let's do a small experiment. Okay, so here I have this engine block file, which consists of 1069 components. Okay, so now I'm opening a step file here. Okay, you can see it took me about 1 minute 59 seconds. Okay, I'll just to save time, I'll just runs. Okay, I'll just, so you can see it took 1 minute 56 seconds. Okay, in this scenario, I'm going to open an inventor file, okay, which is the same model, but it's the inventor file. Okay, I'm just opening it. Just see how fastly this is opening. It just took 52 seconds. Okay, this is how you can see how effectively we can use 3D interconnect collaborating with other native CAD files. Okay, so it is faster, and also you will not get any other errors during the translation from one CAD to another CAD. When you are using neutral CAD, you will have most of the time you will have the lots of face errors or other types of errors. So that will be completely, we can eliminate it here. So you can see here, we have opened this inventor file in 52 seconds. So as you witnessed, so we can, so in this scenario, okay, in this scenario, we have just opened this file, the same data, okay, which is from step file as well as from inventory file. We have opened a 2.1 times faster. Okay, that means 200% faster we can open this file. Okay, this is just an example. Okay, and you have to, for your own applications, you can try whether if it's a Creo or NX, you have to try and use optimal settings to get the better performance instead of going for the standard settings. Okay, so to conclude on 3D interconnect, okay, so whenever you get a chance, just use native CAD files. If you want to access more on neutral CAD files, you have to go and see our webinar part 2. Okay, so so we have learned how to use the native CAD files, what is preferred, and how to use the 3D interconnect effectively in this section. Okay, so next one, what I'm going to take you through is best practices of optimal performance. So in this section, what I'm going to do, all the SolidWorks options, okay, so which will be useful for you to perform better operations. Okay, so this model, this is called truckaway model, and it has almost 2170 components. So initially, this entire assembly was created in 2018. When I opened this complete assembly, okay, in 2023, it took me more than 2 hours to update because of the all the model updation and it's a library part of upgradation. So all the updates is taking so much of time. So it took me more than 2 hours. Okay. So when I opened this same file after saving in the 2023, okay, so it just took me 55 seconds. You can just see the almost how many you can calculate how many times of faster you can do. So this is nothing but you in your assemblies, when some components, okay, are in older version or in total components in older version, you have to convert or you have to save it into the current version to see the faster performances. Okay, so you can just witness here how fastly we can open the entire model here. So it is always we prefer to update the older version files and save it into the current options, whichever current SolidWorks version you are using. So we can see in the next slide how the current version of SolidWorks will be helpful for you to open the files faster. See, it took me 2 hours, and now it is taking me just 55 seconds. Okay, so this is how fast you can use. You can open the larger assemblies in latest version. So you can see here this assembly. Okay, this is the telescope assembly. It has 7,000 more than 7,000 components we have. Okay, so we have a data of various versions of SolidWorks OpenTime. For example, you can see here 2018, 2019, and 2023. So we took all the data and compared how the each versions performed. Okay, so in resolve mode, for example, you can say initially it took 9 minutes, and in 2019 it is taking just 7 minutes. So when comparing with 2019 with the 2016, it's 20% faster. At the same time, when I use the 2023, the current latest version, it took me just 5 minutes. Okay, that means from 2019 to 2023, I have 30% faster. If you compare with 2023 with the 2018, it's almost more than 1.8 times. That means 180% faster. So similarly, this one is what we are talking about is a completely resolve mode. If you are going with a lightweight mode, say for example, 2019 versus 2016, you can see 27% of faster performance here. With the 2023, you can see 4.3% faster when comparing with 2019. Similarly, the large design review also. So for example, you can, so this is the beauty of different modes we can use. So based on your need, you can choose to open which mode you want, resolved or lightweight or large design mode. So for 9 minutes to 45 seconds. So here it's just taking the latest one in 2023, it is just taking 18 seconds to open the complete assembly. 7,000 components assembly. Okay, so for if you get a chance, or I would always recommend you to go for a updated version of SolidWorks. Okay, so latest version of SolidWorks will always performs faster. Okay, I have one more question here for you. So if you would like to, you can just comment on here. To open this kind of a larger assembly, which one would you prefer, or which one will perform faster? Whether if I open it from local drive, or from network, or from PDM, which one? With the image what I've shown here, you can guess. Okay, we'll try to find out the answer. Okay, so whenever you're opening any files, okay, so all the references are going to be checked every time. Okay, so for example, in this case, you can see, so this is the file is not available. Okay, so it is just one example. Similarly, maybe more number of components may be misplaced or moved, and also see, you can see everything is in my local drive. Okay, so when you are accessing a network, okay, from your local machine's RAM, from the server hard drive, it needs to pass through various stages. Okay, for example, see, so server network card, router switch, hub, and network local network cards. So all these stages it needs to cross to reach your local RAM. From the local RAM, it needs to open. Okay, and if in case of local, nothing, it's directly from local hard drive to local RAM. So we can see the performance in various. I've seen in my past experience, using local is always faster. So whenever you are facing any problems with the larger assemblies working with the network, I would prefer you to use the local drive. But if you have a PDM in your organization, okay, I hope the PDM's usage everybody knows. Okay, if you use PDM, the PDM will always have a local cache. Once if you open once, it will have a local cache. From the local cache, it is very easy to open. Even you can sense 5 times faster opening performance. So if you want to see which is the best one, so always the PDM is faster. Whenever you are, if you have a PDM, or if you are thinking about PDM, I always urge you to go through PDM, because PDM will give a better performances in terms of handling the large assemblies. And if no PDM, so local is always preferred. So when you are facing trouble in opening time, or any other performance issues, so from network, you would go for the local if you don't have PDM. Okay, I have an interesting question for you. In hardware, okay, so general recommendations, you know, so we have to use the SolidWorks certified cards, and these are all the general recommendations. So faster CPU core, SSD hard drive, RAM needs to be more than 16 GB. Okay, if I have a question for you, which is the best processor, Xeon or i7 or others? Are these going to be impacting your opening the large assembly? Of course, yes. So when you are dealing with large assemblies, so always benchmark your requirement. Okay, for example, if you are handling the large assemblies, go and test various system specification which is suitable for you. I can take you through the this kind of scenarios in one of our case studies, which we are going to see, where you can sense which processor is faster. Okay, but the application is totally different. For example, if you need to perform longer duration, you have to go for some processes. If you want to the faster performance, you may need to go for i7. So that is why, based on your requirement, you always have to benchmark your system specification before making a buying decision on hardware. Okay, here the next topic, made complexity. So, whenever we are opening any sub-assemblies or top-level assemblies, so all the mates or all the features or all the components, it's going to be loaded, correct? So when you have a lots of mates and when you have a complicated mates, okay, so number of mates and type of mates. For example, if you want to say some example of type of mates which is complicated, maybe tangential one, or which is the mate through the sketches, okay, through the path. So these kind of mates are complicated, number of mates also. So this will definitely impact our rebuild time, performance, editing challenges. So that means when you have a larger components, so you will have a larger mates in top level. So one mate will be depending on multiple components or multiple mates also. So that is where our editing challenges will come. Hence, always reduce the number of mates. How you will do it? So you have to create sub-assemblies effectively so that the top level, that means in a top level assembly, you just reduce number of mates. Instead of putting parts in top level assemblies, you have to create effectively the sub-assemblies. Then take the sub-assemblies and put it in the top level so that number of your mates, and if any complicated mates also will be reduced, so that the mate complexity will be removed completely and you will face the better performances. Okay, the next one is very, very critical, assembly level features. Okay, so for example, when we are creating multiple level of assemblies, suddenly we may need some holes. Okay, so we may create some holes or some other features. The best practice is we should never make any assembly level features into the other parts. Okay, because why? This is the sequence of how our loading is going to happen. Okay, so first it is going to load the components, and it is going to load the mates and assembly features and external references. So when you are going to use assembly features to mate, so we are just expecting you to work in a reverse manner. Okay, so that means we are just rebuilding the pass. So here you can see. So in any case, okay, so we should avoid mating with assembly features, because which will try to rebuild it multiple times. That will always lead to a more time in opening. So don't use assembly features to mate with any other components. And one more best practice is always use the reference geometries. Okay, if you are extensive users of 3D CAD model in larger assemblies, you can always face this problem. Okay, so when you are referencing into any parts or any other surfaces or any edges, so whenever we are rebuilding it, we are going to face challenges. So always or whenever possible, try to mate with the reference geometries like planes, axes, and coordinate systems. Okay, here it is in context feature. In when we are doing top-down designs, okay, so we always take references from other top level components to derive the next level of components to design. Okay, so we need to minimize the in context features. So that means the dependability of other components to be reduced. Maybe during our modeling, we can take what I usually do is during our modeling, in every time we may not need the in context features intact. Okay, so when I do the design, I can take the references of top level components or assemblies. Once I do this required features in the current model, what I always do, I'll go and erase the features of the references which is referring to other components. So that means external components. So this will drastically reduce your opening time or switching time. So it is always preferred minimize or if possible reduce the or avoid the in context features. Okay, circular references. So when the circular references will happen, that means you are going to create one feature, and based on that feature, one more feature is going to be created. Okay, so this means to and fro, the references will be happening to and fro. So when can it happen? So when you are using in context features or dimension or equation dependencies, so this will create the circular references. What it will create the issues, the rebuild error it will throw, and this will always lead to performance degradation. So break the dependency loop and use the external references. Even I said break the external references, but when we compare between these two, instead of circular references, external references are better. If possible, even you can avoid the external references also. So simplify the design so that you can get the best performance from the software, CAD software. Errors. So we need to remove all the errors. So when you are opening an assembly, okay, so if you see this kind of errors, what software will try to do, it will always go and each and every time when it loads or when you switch the windows, it will always try to rebuild. So when rebuilding, it will go through all the errors. Okay, so which will cause the switching times, that means window switching time and other issues. So rebuild errors, mate error, and equation errors. Okay, so you can see the this type of equation error. First resolve all of them. So this will drastically improve your performance time. Okay, the flexible subassemblies will always take much more time. So use the flexible subassemblies wherever necessary. Okay, we no need to use flexible assemblies everywhere, or you can control these features using configurations also. So hence avoid flexible subassemblies. Okay, so which will impact the rebuild and rebuild time. Okay, I think every modeling person should have come through this one. Okay, so when we are using the lots of pattern holes or pattern features, we always see our CAD software will perform very poorly. Okay, so here we need to use simplified geometries, and also we can create configurations using simplified models. Okay, so this will definitely when it comes to and in a part level, it's okay. When it's coming to larger top level assemblies, most of the time it is not required. Okay, so it is always good to go for simplified representation or simplified geometries. In terms of you are using the fasteners, always use our library files. Okay, this is another thing issue. That means we always in a design hurry, we always go and put some if in terms of putting it fully defined, we always leave some mating as it is. That means without fully defining. Okay, so when we are not fully defining, again, as I said earlier, this will whenever we are loading or whenever we are going to switch the windows, it will always try to resolve it. So it is very good practice to use fully define everything. You can see in this truckaway model, I can see maybe 5 components or 5 subassemblies are not completely defined. So fully defined assembly opens and rebuilds much faster than underdefined assembly, as we talk. Unload the hidden components. Okay, so When you are hiding the components, you can have a command in our SolidWorks. Okay, you can unload the hidden components to perform the faster operations. Configurations, use configurations. Instead, when you are importing a models with lots of features, try to optimize using the defeature tool. Okay, or suppress or delete unwanted faces. Okay, so this will go very, very good with the imported models. So configurations are very powerful in large assembly handling. And we are not going to use the top level assemblies always. Okay, hence use the configurations effectively. For example, this track away we have already seen. Again, we can see one more option here. Okay, it consists of more than 2000 components. Okay, when I opened this top level assembly, it took almost 1 minute 4 seconds. Okay, so completely but if you want to open, if you want to work only on chassis, okay, so you don't need to open the full assembly, then hiding the other components or switching to other configuration. Instead of this, you can directly go and open, so you can see the chassis configuration. So in this chassis configuration, you can open, it just opens in 13 seconds. So that means when you are working in a multiple teams, we can expect that multiple team members are going to work on different subsystems. Okay, it is always good to create based on your team's need the configurations and use it effectively. In my experience, I can say only in few times we have get a chance to during the product designing time, only few times, that may be 2 or 3% of time only we may need to work on top level. Other times we have to create the representations or configurations for different team members to effectively use it. So similar to the configurations, we can create display states also, where we can you can see the most of our computers RAM is going to take our visual appearances effects, and instead of hide and show, we can just completely use the display state to effectively improve the performance of the CAD softwares. So in these cases, we may not need to rebuild also. Okay, so when rebuilding is not required, always it's going to be faster. Okay, to summarize on this point number 2, so it is always use latest version of CAD. When you are getting chance, use local drive or PDM, and all the best practices what we discussed now. You can use all those things to improve your performance. Okay, next we are going to see the power of 3D Experience SolidWorks, where I'm going to cover only a very basic thing. Okay, so it's going to be a very a shorter session. Also, I'm just approaching the time. Okay, I'll quickly launch the second poll. Just a minute.
Prakash,
yeah,
do you want to launch it?
Yes. 1 minute. I'm just.
Yeah, I've just launched the poll too. Okay.
Yes. Thanks, Pradeep.
Yeah.
Okay, so these poll questions may be related with whatever the sessions which we covered. Are you using PDM and PLM in your organization? How familiar are you with explained best practices? Okay, the third question is, have you implemented any specific strategies or techniques to optimize the performance of large assemblies in 3D in SolidWorks? So we can wait for 30 seconds more to end the poll. I can see only 50% of polling answers. Guys, please answer these poll questions. Okay, in 10 seconds, I'll be ending this poll. Meanwhile, I can share the details. So okay, 63% of our participants are not using the any PDM. So whatever the discussed best practices, I think most of our guys are using 50% of whatever I shared. I think they are already using it. Thank you. I'll end the poll now. Okay, as I said, I'll take you quickly through the 3D experience part. Okay, if you are not well aware about it, our 3D experience SolidWorks comes with a powerful PLM Enovia. Okay, in Enovia, what all we can do it. So you can visualize the 3D CAD in seconds. You no need to have a separate CAD softwares. You can explore the CAD structures, and you can find products, and even you can create structures as well. Okay, so it is like you can review the whatever the CAD files it is in Enovia, which it is completely web-based applications. Okay, and you can group and filter CAD to your needs. That means you can create different configurations in Enovia platform itself. So for designers who's collaborating with the different subsystems can use it. Most of the times, large assemblies are used for reviews only. Okay, so managers can use it. How effectively the 3D Experience SolidWorks can be used with the Enovia? Okay, so so no CAD software. So just now it's just a browser. At any browsers you can see, at any device, anywhere you can see it. So we can see in next slide, we can see the larger assembly which is opening. You can personalize your needs based on your different requirement. For example, different subsystems or different level of manufacturing, or in any level of filtering, you can use it so that effectively you can handle the large assemblies there. Okay, as a designer or as a manager, as a collaborator, or even as a marketing or salespeople, everybody can access the data from the Enovia in 3D Experience SolidWorks. Okay, so here I'm just going to take you through the Resamin bolter, which is our one of the largest assemblies. Okay, it is going to take very less time. You can see, as I said, the large assemblies, top level assemblies, mostly opened of our reviews. Okay, that too with the management or with the managers, or so here you can use all the features available here. That means you can measure it, you can hide it, you can do exploded views, you can create sections, you can completely review. Okay, so this one is completely web-based. You may not know, you may not require any CAD software also. So I see this is excellent way of handling or managing the large assemblies here. Okay, so we need to cover more on 3D experience SolidWorks. We can see some other sessions where we can effectively go and use the 3D experience SolidWorks extensively for large assemblies. For this one, I think, as I said, this is going to be just a simple introduction for this one. So you can, in 3D experience SolidWorks, you can see 3D product architecture or 3D product explorer. You can use, visualize, you can review these kind of activities, which is necessary for large assemblies. Okay, much weighted this practical case studies. Okay, so I'm going to share 2 case studies here. Okay, case study 1 here. This is a customer. These are the customer challenges. Okay, this customer is automotive related customer. Okay, so opening and importing step files took almost 2 hours. Okay, their main issue is opening performance. As I earlier said, when you are selecting the hardware, you need to know what you are going to perform, right? For this customer, the opening time is very essential. So to give a output for their customers on time. Okay, so you can see they are using 2016 and the CAD file. Usually they are getting a step files. The typical file size is going to be almost 200 MBs, and current open time is 2 hours. Okay, what are all the solutions we have implemented? Okay, so we have recommended to go for latest version of SolidWorks, and so whatever we discussed, all the best practices, right, in part 1, part 2, and now. So we have implemented, and also we recommended them to go for i7 processor. So now we can see how the performances are listed here. For example, so with Xeon processor, the file size which we took 400 MB, okay, which is the worst case scenario for customer. And it is in 2016, it is taking more than 2 hours. In 2022, it is taking 19 minutes. In 2023, just see it is 16 minutes. Okay, so when we are comparing with 2016, 2022 is 6.3 times faster, and 2023 is 7.5 times faster. When we are comparing 2022 and 2023, it's still 18% faster. So that is why we recommended you to go for a latest version, because all the enhancement are going to be useful when you are handling the large assemblies. And the same model and the same machine we have used with not same machine, with the machine with the i7 processor we have used. Okay, so same, everything is same. Here 2016, see, you can see here. We can compare the processes here. Here in 2016 took 45 minutes, and in 2023 it took only 30 minutes. That means 3.5 times faster. i7. Okay, so when we are comparing the processor Xeon and i7 processor, so you can see in 2016 it took more than 2 hours, and it's just took 20 in i7 it took just 45 minutes. In Xeon processor 2023 16 minutes, and i7 is 13 minutes. Okay, so you can see 2.6x faster than Xeon processor and 23% faster here in 2023. Okay, so that is why it is not a hard and fast rule that you need to go for this one, but it is always recommended to go for a benchmarking. Okay, so based on that, you can what is your need for it? Okay, so when you are going to work on larger assembly for larger duration, may not be i7 may not be a suitable solutions. Okay, because Xeon processors are built for endurance and i7 is built for speed. Okay, let's go for case study 2. This customer is also automotive related customer. Okay, the major customer challenge is time to open the assembly is taking so much time and slowness while using the with other commands like switching the windows and other options. So customer still using 2022 CAD type of files. It is SolidWorks files, but lots of imported geometries. Okay, more than 70% of imported geometries, and their typical file sizes are more than 1 GB. The number of parts is 9,000 approximately. So we have provided solutions. Okay, before that, what are the solutions we have provided? I can take you through this one. So before and after, you can see it is taking 6 minutes previously. Now after the modification, it is just taking 4 minutes 26 seconds. It means 26% faster. You can see how the solutions which we implemented, okay, are effective here. Almost 75% of faster opening time we have seen. So during window switching, okay, so which is one of the very, when you are switching the windows, when you have to wait, sometimes it will test our patience, right? Okay, let's go for what are all the things. Okay, in entire assembly, we just took 3 largest step files and cleaned. Okay, and we have enabled the freeze bar because since this component is full of imported geometries, always whenever you're trying to open it, or whenever you're trying to switch the planes, or when you're do some other commands, the assembly is trying to resolve all the failed features, even in the imported geometries. So we enable the freeze bar, and large assembly settings has been updated. And based on the performance evaluation tool, we have reduced the image quality of some of the components, which are shown in a larger value, upgraded the files to latest version. So if you go through these things, you will understand that whatever we have discussed, everything is being used here. So use of a large design review and the speed pack configurations, and the use of the configurations effectively. And also the graphics card was updated. NVIDIA settings is made optimized for the customer's requirement. All the systems options and document properties have been updated. Okay, so these are the implemented solution. So now you can see again the results. Okay, so the opening time, the completely opening time is saved 26% faster. Rebuild time 67% faster. Save time, sometimes saving is also a little painful, right? So that is 33%. So these are the two case studies. I have many case studies like this, but these two are more interesting and related with our large assembly perspective. Okay, so in when we are using large assemblies, use appropriate best practices. Okay, so if you need more ideas, you have to visit part 1, part 2, and part 3 webinar series. You can use these are all just an introduction of our various tools. This is not complete. This is the just introduction of all the tools, where you can always use these tools in different combinations to resolve your large assembly challenges. We have almost come through our end of the webinar. Okay, so I just to summarize, in multi-CAD collaboration, always go for native CAD files whenever is possible. That is the preferred one. Use 3D Connect effectively. And also always use latest version of software. So you have seen in case studies that performs better. Also, always, if possible, use PDM or local drives whenever you are facing challenges with the large assemblies. Use all the best modeling practices, which was discussed earlier. 3 experience SolidWorks comes with a powerful NOVIA PLM. Okay, we have to you can explore more on its features, how to handle the large assemblies using the 3D product architecture or 3D product explorer. Okay, and we can always use that tool for complete review. In practical studies, we have seen how 2 different problems are resolved. Okay, so use appropriate best practices to resolve your all practical large assembly issues. Okay, now it's almost 1 hour. I can take some time, maybe 5 minutes, if it's okay. The question answers. Okay. Yes, you will get the current session recordings also, Mr. Gokula Krishnan. Okay, so most of the questions are regarding the QR codes. So yes, you will get the QR codes. I've shown you the QR codes previously. If you want, I'll take you through that slide before end of the session. Just a minute. Okay, to answer Srinivas Reddy. So it is not a straightforward answer. So you have to use multiple options to optimize the SolidWorks for large assemblies, particularly. Do we need to buy a license for 3D Experience SolidWorks? Okay. Currently, if you all the SolidWorks from July, it comes up with the basic 3D experience. That means 3D Experience platform. Also, you can get the PDM as well as the basic PLM features. So you can also buy the 3D Experience separately. Also, if you already have SolidWorks in your company. So we are using SolidWorks 2011. How do we improve the large assembly performance? So the latest versions have been improved multiple times. Okay, so we would recommend you to go for the latest version of SolidWorks, which will resolve all of your problem of large assembly handling. Number of parts in my machine is 26,880 originally. After creating display state, it is showing 27,330. Maybe we need to explore more on your assembly, Mr. Venkat Narayana, but I suspect maybe in a display state needs to be recreated. That means you need to unload all the already created display state, and you may need to recreate it, so that you will get the proper answer. Okay, it is taking lots of time to save files. How to save files quickly? Okay, this has been answered during our presentation. Okay, so use all the best practices which we shared. Was wondering if 3D Experience proves helpful to show part components more separately. 3D Experience is a very powerful. Okay, so for example, if you just want to see the component, or if you want to review it, or if even you can do the markups. So it is powerful. And if you need more details, Mr. Barsha, you can, sorry, Kuzima Barsha, you can always reach us. Okay, we can help you. IFC file conversion. IFC file conversion taking lots of time in our system. We are having around 40,000 components. Okay, so I've explained in one of the case studies, okay, which is 9,000 components, right? So similar to that one, and that is more with the imported geometries. So that solution or those solution features will help you to resolve this one, Mr. Sadivada. Okay, Srinivas ready for 2021 version Xeon or i7. So as I already said, you cannot just decide it based on your requirement. And I always recommend you to go for the benchmarking for your use. So you can select whichever best suits. I'll take 2 more questions. It's already we are in 4 o'clock.
Yes, 7. So you can choose 2 questions, and any questions which are still unanswered, please drop us an email, and we will address those questions separately, on one-on-one basis for sure.
Of course, yes. So what are the settings need to optimize the graphics card? What are the settings need to optimize the graphics card? The large assembly settings, which is explained in part 1, that should be sufficient to optimize your graphics performance. So you can refer Mr. Shankar T. You can refer part 1. Can we convert a step file format with a display state? Yeah, once the step files is imported into a SolidWorks, you can do whatever you're doing with the SolidWorks files. As native, you can create it. Thanks for all of you for joining this session. It is very much satisfying for me to share our knowledge with all of you because we thought sharing the large assembly best practices with you will be much more helpful in terms of your day-to-day activities when you are handling the large assemblies. Thanks for joining this webinar, as well as I would recommend strongly go through the part 1 and part 2. Just a minute before you leave, I'll just showcase the QR codes for the part 1 and part 2 also, so that if you want, you can take a snapshot. Yeah, here are the QR code for accessing the part 1 and part 2. You can take the snapshots and request for the access. Yeah, thank you all. Thank you very much.
Thank you so much.
Yeah, thanks.
Thank you, everyone. Thank you for attending today's webinar.